In this chapter, no sooner do we learn a new definition, like the complement, that we also learn how it affects probabilities that we need to find. So we're going to look at the complement rule, which is rule number 3 in our list of probability rules. So the complement rule says that if you have an event E and you have its complement, E complement, then the probability of E and E complement must add up to 1. In other words, the probability of E complement, which is the probability of not getting E, is 1 minus the probability of E. I'm going to write it over here as the other way. So the probability of E plus the probability of E complement equals 1. That's another way to think about it, right? Because of what we're saying down here, the event E and its complement have to make up the whole sample space because they're disjoint. There is no item that is not included in either E or E complement in the sample space. So they cover the entire sample space, so they have to add up to 100%. All right, so let's look at what this means in practice. So we're going to take our standard 52 card deck, which we know and love, and we're going to figure out some probabilities from it. All right, so first thing is, what is the probability of Q complement? Right, Q with a little c after it, that's the probability of Q complement. It's the probability of not getting a Q, which is 1 minus the probability of Q, which is 1 minus 4 out of 52, because there's 4 queen cards on a deck. Now at this point, we have to take a trip back down memory lane in our mathematical lives to remember that 1 can turn into anything over itself, I should say. And then you're thinking, why am I mentioning that? Well, because when you want to add and subtract fractions, you need them to have a common denominator, if you might remember that from school. So what I'm going to do is I'm going to turn 1 into 52 out of 52. Think about it. It's the whole deck. So the whole deck becomes 52 cards, right? You have 52 cards out of 52 cards. And you're going to subtract away 4 out of 52, which means you're left with 48 out of 52. Now I can prove that to you several ways, but let me grab Desmos. If I just say 52 take away 48, sure enough it's 4. If I say 1 take away 48 out of 52, it looks different because it's a decimal. If you click the little fraction button over here, it turns into a reduced fraction. And you might be thinking, oh no, that's not the same thing at all. Oops, 4 out of 52, not 48. There we go. So it's 12 out of 13. So then if I take 12 out of 13, or see 48 out of 52, I can see that's also 12 out of 13. This is a reduced fraction over here. They figured out that 48 is divisible by 4 and 52 is divisible by 4, so that's what it's doing. So as a reduced fraction, it would be 12 out of 13. Either one is correct. It's just kind of whatever you feel like working with. Of course, the decimal is also correct, but the decimal would require an approximation sign because you're rounding with the decimal. Okay, so then what is the probability of not getting an ace? Well, that's going to be the same thing, right? Because there's 4 aces in a deck. So ace complement, so the probability of not getting an ace would be 1 minus the probability of an ace, which is 1 minus 4 out of 52, which is 48 out of 52. Really easy. All right, now what about the heart complement? Interesting. Okay, so the probability of heart complement, which is the probability of not getting a heart, is 1 take away the probability of a heart. It just occurs to me I'm getting lazy with my ones there. All right, so that's 1 take away 13 out of 52, which is, okay, so I'm going to turn this 13 or this 1 here into 52 out of 52. So there's the full deck. I take away the 13 out of 52 heart cards, and I'm left with 39 out of 52. Now, some of you might have realized there's another way to think about this, because if you think about the deck of cards from our sheet right here, you can see that hearts are one of the 4 suits. So 1/4 of the cards are hearts. So instead of doing 13 out of 52, you could have done 1 take away 1/4, right? Which is 4 out of 4, right? You turn the 1 into whatever you want so it has the common denominator. So you put the denominator over itself. And then take away 1/4, which is 3/4. And if you're thinking these aren't the same, they are. Right? 39 out of 52 is 3/4. It's 0.75. I can prove it to you. So 1 take away 13 out of 52 is 0.75, which is 3/4. There you go. Which is, of course, the same as 1 take away 1/4. It's all the same. All right. Now, what about not getting a face card? So what's the probability of no face card? All right. Well, the probability of face complement, which is the probability of not getting a face card. And if you're thinking, do I have to show all this work all the time? The answer is no, not necessarily. But for your notes, you want to write it all down because you want to be able to refer back to this and know what you were doing. So there's 12 face cards in the deck, right? King, queen, and jack for the 4 suits. So I would turn that into 52 out of 52. And again, I usually do that in my head. Even if I do show work, I generally don't show the 52 out of 52. I just kind of think about it. Think, okay, well, there's a deck. It's got 52 cards. If I take away the 12 face cards, there's 40 remaining non-face cards, which would be 10 out of 13 if you did a reduced fraction. I can prove it. 1 take away 12 out of 52 is 10 out of 13. All right, I'm going to add a question down here that's not currently in the notes if you're watching this in spring 2023, but it will be for future. So I suppose you place a bet that the card drawn will be a queen or an ace. What is the probability that you lose? All right, I'm getting us prepped a little bit for chapter 6 here. So if you think about it, the probability that you win is, I'm just going to write this down, is the probability that it's a queen or an ace, which we learned how to do a couple pages ago. That's the probability of queen plus the probability of an ace, which is 4 out of 52, plus 4 out of 52, which is 8 out of 52. Right? Because they're disjoint events, we can just add them up. Done. So the probability that you lose is the probability that it's not a queen nor an ace. So that is 1 take away the probability of queen or ace. I don't know why I put that extra parentheses in there, right? So that is 1 take away 8 out of 52. Okay, well again, kind of make that 52 in your head. 52 out of 52, take away 8 out of 52 would get us, well, 52, take away that would be 44 out of 52. So let me prove it to you. 52 take away 8 is 44. So according to me, it's 44 out of 52. Let me try 1 take away 8 out of 52. Lo and behold, they're the same. And if you want a reduced fraction, it's 11 over 13. I usually don't ask for reduced fractions, but just so you're aware, that's what Desmos gives you. So you might have to manipulate it a little bit to make sure it's the same answer that you're writing. You can always check the decimals with each other, right? So if you think it's 44 out of 52, you get 0.846. And then, if Desmos gives you 11 out of 13, you can see, oh, it's the same thing.